So my name's Christopher Spring. I'm going to be doing a presentation about JRuby and TorqueBox and pretty much how they give me a warm, fuzzy feeling inside, and I think it'll do exactly the same thing for you guys as well. I work at Mad Mimi. You can get hold of me on Twitter at Autonomous, or if you'd like to harass me via email, chris.spring@gmail. So firstly, when I talk about JRuby, it's not really to bash MRI or bash any other implementation of Ruby. It's all kind of part of the same ecosystem of caring. It's still Ruby that we all love and like, but just running in a different way. So with that out of the way, let's bash Java a little bit. So Java is a DSL for converting large XML files into stack traces. So that's actually all that you need to know about Java to run JRuby. So you don't have to write Java, you don't have to learn Java. It just happens to run on something that usually is run with Java. So let's jump straight into JRuby and have a look at the structure of it. So Charles Nutter at Heroku last year kind of described this as the structure of JRuby and the JVM. So if you look at the top box, the green box, all that you're doing is you're making Ruby available to the JVM. That's really all that's happening up there. And then the JVM is responsible for things like threading, the garbage collector, how stuff runs on the actual machine. So this is quite cool. If you're on the JRuby core team, that's all that you care about. You don't have to worry about the kind of garbage collector that's implemented. So they're in a pretty cool position where they can stop working on JRuby and it would continue to get faster because of the work done on the JVM. So, speaking about performance, I'm going to do a couple of unfair benchmarks. So I've noticed that there's a lot of talk about Fibonacci, and it seems like somebody's going to release a Fibonacci series server any day now. So I thought it would be a good candidate for a benchmark. So this is a nice brute force implementation of the Fibonacci series. We're working out the first 40 numbers in the series and just putting it into an array and seeing how long that takes to run. So what's quite cool with this implementation is that you've got this really nice deep stack of method calls. So MRI, Ruby 1.9.3, runs it in a little bit under 53 seconds, and running it on JRuby takes 10.4 seconds. So that kind of performance disparity is not, you can't ignore that. You kind of have to pay attention to that. For those of you interested, on Ruby Enterprise Edition, that same benchmark took 183 seconds. But that also kind of shows you how far Ruby has come in terms of becoming better and getting faster and solving our needs. So most of us are doing web development, so I thought I'd do a quick little Sinatra example. I don't trust multi-JSON, so we're encoding that particular hash 1,000 times just to make sure that we're doing it right. So if you go to the root, you encode that hash 1,000 times, and then you return it back to whoever's asking for it. So we're specifically using Puma here. So Puma wants to run in a multi-threaded way. I used Apache Benchmark, 1,000 requests with a concurrency of 32 to test out that endpoint. Specifically with a concurrency of 32 because Puma has a default concurrency of 16. So I wanted to stress it a little bit. So on MRI, it kind of used half of the cores on the machine. And that's because of the global interpreter lock. And I'll get into that more in a second. And that benchmark took a little under 25 seconds to run. So then I fired it up on JRuby to see what would happen, and it lit up every single one of the cores. So that's one process using all of the hardware that's available to it. And that first run took about 8.5 seconds. So then I thought, cool, well, let me leave this Puma server up and running on JRuby and see what happens when I run the test again. Still lights up all of the cores, but not for nearly as long. And that last one took about a little bit less than 3 seconds. So kind of what we're seeing here is that JRuby is getting faster the more we let it run. And it kind of tapers off at that like 3-second mark. And we're starting to get an idea that JRuby is maybe doing some extra stuff, or rather the JVM is doing some extra stuff to make our code run a little bit faster. So the kind of optimizations that we might see is, let's suppose you've got this scenario. You've got method 1 calls method 2, which in turn calls method 3. So Konstantin spoke a little bit about Invoke Dynamic. There was a whole lot of JRuby logic that went in there that Invoke Dynamic essentially gets rid of. You don't have to explain that to the JVM. So let's take a step back, actually. Let's consider compiled languages. So a compiled language can only make so many optimizations because it doesn't understand how your code is going to run necessarily. But because you're running JRuby on the JVM, it can look at how your code is running and do some cool optimizations based on what it sees. So the expensive part here, for example, is that dispatch, that method call between method 1 and method 2. So what JRuby can do is it can inline those methods into each other so you get rid of the expense of that dispatch, of that method call. We've also started getting an idea of that JRuby uses a different kind of threading implementation to normal MRI. So where we were kind of using half of the cores on the machine, JRuby would light up the entire machine. So JRuby doesn't have a global interpreter lock. So that means you can run 2 pieces of Ruby code at the same time on 2 different cores, which is why you see that. Why you see all of the cores being lit up like that. It uses native threads. You've kind of seen that in 193 as well. And you're starting to hit this place where you can completely utilize all of the resources you have at your disposal with one process. So let's consider concurrency thresholds for a while. Think about the expense of something like a process versus the expense of something like threads. So you can only have so many processes, but you can have so many more threads. You can also have so many more green threads, but they've got their own set of advantages and disadvantages. So in terms of memory footprint, a 100 process system versus a 100 thread system, the green one is a lot lighter than the red one. Consequently, it's also a hell of a lot more flexible when you're dealing with things like, imagine a DOS attack on something that's reliant on forking out processes as opposed to something that's reliant on forking out threads. So the other thing that's worth considering is the Java community is massive. Java's been running on some pretty hardcore systems for a really, really long time in some pretty demanding applications. So it's kind of unfair to think that, well, just because Java is uncool as a language, that we should completely ignore some of the stuff that that community has come up with. We might as well, as the Ruby community, take advantage of some of that stuff. So here's a nice trivial example of how we're going to use a Java library. So let's assume that we've got our Rails application, we've already built out all of our views, and somewhere down the line we decide we want to turn one of our views into a PDF. So I don't necessarily want to jump into something like prawn and redo all of that work in a separate DSL. I'd much rather use the tools that I understand well, CSS and HTML. So there's this great Java library called the Flying Saucer. Getting access to it is really easy. It's just gem install Flying Saucer. So all that's happening in this example, that string IO, that's what we're going to put our PDF into. Flying Saucer and iText, which is kind of like the Java world's PDF writer or prawn, I guess. That gives you access to that iText renderer. That's going to do all of the work. You open up that HTML file I showed you, tell iText renderer to turn that into a PDF, and then finally we save that result into a PDF. So that's what the HTML looks like. You can tell I've got a design degree. And that's what the PDF looked like. So if you consider, you can shove any HTML page into that snippet of code, and it'll generate a PDF for you. That's pretty cool stuff. So there's obviously a hell of a lot more to JRuby and the world of Java that we can exploit. Obviously, Java and the JVM, it's cross-platform. Java runs on phones. We can do GUI applications. So all of a sudden, you can take your Ruby skills and apply it to many more markets, which is great stuff. Konstantin mentioned Visual VM. The tooling in the Java world it's insanely good. So with Visual VM, you can attach to a local process, or you can attach to some remote process and look and see what's happening with your processes. And also the ecosystem from the Java side is huge. I think Charles Nutter said 35,000 gems on rubygems.org last year at JRuby. On Maven Central, there's 340,000 versioned libraries. So that's a massive pool that we could tap into as Ruby developers. So that was kind of like a lightning introduction to JRuby. And I kind of want to have a look at TorqueBox, but first take a step back to have a look at how we're implementing Rails applications. So you create your Rails application, everything goes well, you start to get more customers, and everything starts to get a little bit slower. So you realize that sending emails in your controllers is maybe not such a good idea, and you start taking things out of your request cycle. So you do what any of the cool kids would do, is you would implement Sidekick. But Sidekick has dependencies. You've got some background process that runs runs Sidekick. Sidekick is dependent on Redis, and it's got to run somewhere. So what happens if Sidekick just falls over or Redis goes away? You need some kind of a contingency plan there. You need to be able to roll over to something. You've got to put complexity into your architecture to manage that for you. Similarly, you decide, well, you've got a nightly billing run that you want to do. So chances are you're probably going to run that with cron, which runs on a machine somewhere in your environment. So with this in mind, let's now have a look at TorqueBox. So I kind of want you to think of TorqueBox as this beautiful big blue universe that on the one hand can interact with the outside world. You can shove Apache in front of it. You can hit it up on port 8080. And then on the other hand, you can take any number of your applications and simply deploy them into that big blue universe. What's quite cool is that all of your apps suddenly have access to a whole bunch of cool things like background jobs, scheduled tasks, asynchronous messaging, and so forth. And it's kind of like installing a Ruby gem into your application. Once you've got that gem in there, you've got this really nice Ruby API that you can interact with those services through. So this is kind of the scary part for me. All of this stuff runs on JBoss. But why that's cool is that JBoss kind of understands clustering. So this beautiful big blue universe can run on any number of nodes. So if you've got a scheduled task that's going to run on node A, and if that node goes away, TorqueBox knows, cool, I don't have to worry about that node, but I'll make sure that that cron job runs somewhere else. So just consider the previous situation we were in where we had Sidekick and cron running on a machine. We don't have to build complexity into our systems to take care of that kind of stuff. JBoss also knows how to load balance our work between the different nodes. And it's also got high availability built into it. Just kind of like as a side note, some of the toys that TorqueBox uses to implement this functionality, hornetq, that's its queuing system. It uses InfiniSpan as its data grid, and Quartz Scheduler for the cron style scheduling. If you went over to the TorqueBox site, they'd show you this graphic, and it's essentially the same as that big blue TorqueBox universe. But from a Ruby and Rails, and essentially a Sinatra or a Rack developer, it's really just business as usual. You're still just writing Ruby. You're interacting with those background services and that extra stuff that TorqueBox provides you using Ruby. So I'll show you a quick example of just getting some stuff into a background worker. So let's say we've got this scenario. You've got a charge, it's got a primary key. A charge is for a certain amount in cents, and a charge has a status, which is pending by default. So in the life cycle of the charge, you're going to want to send it off to a payment processor. So that's an external third-party call to some payment processor. You want to notify the users of your system about the status of that charge. If the charge is successful, generate a PDF and probably mail that off to somebody. So you don't want to shove all of this stuff in your request cycle because you're going to make your site unsnappy. You're going to tie up resources. So that's a possible implementation of the controller side, of creating the charge and then shoving it into a background process to get processed, to send it off to the payment gateway. So it's typical. We create our charge, just standard Rails stuff. That part over there is the important part. You're asking TorqueBox for the charges queue, and then you're just shoving a charge ID onto that queue, which you can then later use somehow. And then we redirect our user with a cute message somewhere else. So we need to be able to tell TorqueBox anything that goes into the charges queue has to be processed by something. And that's where the TorqueBox configuration file comes in. We tell it there's a queue called charges, and anything that goes into that queue has to be processed by the charge processor. And that's what a charge processor would look like. You've got these two hooks that you can tie into. So whenever something goes into the queue, that same thing will be passed to a new charge processor's onMessage method call. And that's where you would put all of your business logic. If you wanted to, you can decide to handle any errors. So if there's an exception in onMessage, that exception gets passed into onError. If you don't do that onError, TorqueBox will retry the error to its satisfaction. So there's a possible implementation of that onMessage. So it passed in a charge ID, and that's what we're using to find our original charge again. We send that off to our payment gateway to get processed. If the result is successful, let's create a receipt and then let everybody know about the status of that charge. And then you can kind of see that whole cycle starting again. To create a receipt, we'll just have some receipt background processor, and we're going to shove our charge ID into it, and we're going to let it worry about generating the receipt. Broadcasting the status, I want to introduce a new idea. So we've got queues, but we've also got topics. So a queue goes to a single processor, but a topic goes to multiple processors. So in the case of charge status, we might want to notify the user. If the charge is unsuccessful, we might want to perform some kind of an admin test or notify an admin just to check that our infrastructure is still in place. So topic would be an appropriate tool there. And it's essentially just the same as a queue. We declare it in our configuration file and tell it whenever we get a charge status topic being put into the queue, notify the following processors. Can we do WebSockets with TorqueBox? Yep. And it's actually pretty damn easy. So it's a little bit of a mind bender. So this is kind of the scenario that we've got. We've got a charge status going into a queue. We've got a stomplet up at the top, and that's very much like a controller in the traditional MVC sense. And then in this scenario, the client would be a web browser. It's somebody we want to push status to. So stomplet, that name comes from STOMP, which stands for Stream-Oriented Messaging Protocol. And it's just a protocol wrapper around WebSockets. So the client subscribes to the stomplet controller, and it's going to be via stomp status's root. And whenever a client subscribes to that stomplet, we're going to tell it that it's got to be interested in charge status topics. Everybody with me there? So whenever we get a charge status, it goes through the stomplet and gets pushed down to the client in the browser. So again, we've got to tell TorqueBox how to do all of this stuff. So we tell it the stomp status route is handled by the charge status stomplet, which is a controller. So what's interesting about the that stomplet controller is that it lives for a long time. It's a long-living process, and it's stateful. So you can start to do some pretty interesting stuff there. All that's happening in this code is whenever a client subscribes to this stomplet controller, it's saying, hey, any charge status has to be pushed down to the client. So you see here you've got on status that you can tie into, then configure, destroy, on unsubscribe, on message. Those are handles that are defined by the stomp protocol. And then on the client side, it's just a matter of including some JavaScript. When the page is ready, you create a client which subscribes to that stomp controller, and any messages that get pushed through from that charge status topic will just be an alert pop-up. So if you think about all of the stuff that we've seen here, it's a really simple setup. There's no third party. You don't have pusher app in place. You don't have to worry about managing different kinds of infrastructure like Node.js or Event Machine or any of that stuff. It's just all built into one beautiful big blue universe, TorqueBox. So I've been working with JRuby and TorqueBox for the last 6 months or so. It's made me feel really, really good about development. I really think it's all unicorns, rainbows, and love. So that was just a really quick introduction. I hope you're kind of interested to pursue it a little bit more. I'd love to chat with you guys a little bit more if you're interested in JRuby and TorqueBox. Thank you very much for listening. And if you've got any questions, go for it. Shoot. I haven't actually gone that route. My interest in TorqueBox has been, so at Mad Meme we've got a pretty big megalithic app, and we're kind of pulling chunks out of it. So we've got interaction between two different infrastructures, but we haven't quite gone the route of putting two applications inside of the TorqueBox universe.
So if you wanted to do that, you have to
Yeah, I think that you can, because when you fetch a queue from TorqueBox with a particular description, that description should be available for all of the applications, if that makes sense. Let's actually jump back a couple of slides. Well, it doesn't have to be on the same server. It's just in the same container. Oh, yeah, cool. Shoot, go for it.
JRuby is using hornetq as its default and QP implementation. It doesn't necessarily use HackQ on that end. So I can use some other. You can go and drop down a standalone hornetq and hold your JRuby stuff using the same one. You can plug in a standard Ruby application into the same place.
Yeah, I guess so, because it's just the same descriptor that you're really asking for from.
As assumed, that hence the TorqueBox actually just using a nice library for
Yeah. Go, Patrick. Sure. So the question was about deployment. And public-facing services specifically for. So I'll answer the second part first. In terms of services available for TorqueBox, I'm sure from the Java world there must be stuff for it. We've kind of gone the route of setting up the metal ourselves and getting TorqueBox running on that. We use Apache with mod cluster. To kind of like, get the balancing done for us. So yeah, we just went build it ourselves from the ground up. There are a couple of strategies that you can take with deploying a JRuby application into JBoss. So the one is you can kind of like bundle all of it into this war file, which you can then give to TorqueBox, and it'll know what to do with it. If you'd like to take the more traditional approach of like a Capistrano deployment, you can do that as well. So it's just a git pull, hey TorqueBox, redeploy this application. So it's really, it's quite easy to get the deployment right. Any other questions? Yeah.
I've got two questions. First off, you mentioned that the queues can be, the queue service can be swapped out. How much of the other thing TorqueBox can be swapped out for other services? Is it like component-based services or you start using a different service or is that out?
I haven't tried to swap things out. I haven't seen the need to swap it out for anything else. JBoss has this huge configuration file where it sets up all sorts of components. It's a big XML file, which is a scary thing to look at. And it's massive, it's thousands of lines. But it sets up all sorts of components inside of that file. So I imagine that's kind of where you would start, flipping out different components into it.
And then the second question, coming from reference Ruby implementation using James, what's the compatibility like with popular gems and TorqueBox?
Popular gems are perfect, they're fine. If you can't use the C extension version, chances are there is a Java version of it as well, like Nokogiri, for example. That just works out of the box. The Ruby Racer, you've got to swap that out for the Ruby Rhino. It's starting to become really, really rare that you can't find the Java equivalent of it. So I found it to be actually quite painless. Yo.
How does JRuby mix with the Java concepts of annotations and annotation processes, things like J, Spring? I don't know how well you've ever touched on this.
No, not really. The last time I looked at that, pure Java, from being a pure Java developer, is Java 5. I have absolutely no idea how that would even, I don't know what that looks like, to be honest. So, and I guess kind of like a half answer to that question is, JRuby is just another jar that you can stick into your environment. So if you wanted to have access to JRuby inside of your existing infrastructure, you should be able to do it quite easily. It's just another library.
But it's a mixture that gets a little bit more complicated.
Yeah, I don't have any experience with that kind of stuff at all. Yo. So the question was, has there been a comparison, a performance comparison between normal MRI and an MRI application versus the same application in JRuby? The TorqueBox guys did a benchmark. So they did a benchmark against Trinidad, Passenger, a couple of others using the Spree e-commerce Rails application. TorqueBox pretty much smoked everything out there. It was much faster. It was much more stable for large numbers of requests. Its memory footprint was incredibly stable over that period as well. It's an excellent, high-quality piece of software. It performs well. Yeah, I think so. Any questions? Cool. Thanks, guys.